Hello everyone, I'm Aylin. Just like every Thursday, we are here again this week with a new topic, which is fire detection and alarm systems in hotels. So let's begin. Hotels are complex facilities that you know and that accommodate a large number of people simultaneously. Therefore, fire safety is critical to ensuring the safety of both guests and staff. Fire detection and alarm systems allow for rapid intervention by detecting a potential fire at the earliest stage and ensure the efficient management of evacuation processes. In this presentation, we'll discuss the basic principles, components, and safety advantages of fire detection and alarm systems used in hotels. So, fire detection systems used in hotels are integrated structures where multiple devices work together to ensure guest safety and provide early intervention capabilities. And the most common devices in these systems are smoke detectors, optical or ionization type, and primarily used to detect early signs of fire in rooms and corridors such as smoke, while heat detectors are preferred in areas such as kitchens and boiler rooms to prevent false alarms. And beam smoke detectors can also be used for open areas or rooms with high ceilings. And manual fire alarm call points are included for manual triggering and are activated by users in case of fire. And sounders or beacons, warning devices, and voice alarm systems are activated to provide warnings in case of an alarm. And all these devices are monitored and managed by Fire Alarm Control Panel, and the panel evaluates the incoming signals and automatically initiates the necessary scenarios. So in addition, automation integrations such as elevator control, door closing or opening, and ventilation system shutdown during a fire are also an important and significant part of this system. So fire detection and evacuation in hotels is a critical safety mechanism that proceeds automatically according to a specific sequence and scenario. So the process begins when the first signs of the fire are detected by smoke or heat detectors, and this information is transmitted to the fire alarm control panel. Then the panel evaluates the incoming signal and initiates a pre-alarm or general alarm, and at this stage, sounders and beacons lights are activated on the relevant floor and designated areas. Then evacuation instructions are given to guests and staff via the public address system. And as the part of the fire scenario, elevators are sent to the safe floor and deactivated. And fire doors closes automatically, and also ventilation systems are shut down to prevent the spread of smoke. And simultaneously, an automatic notification can be sent to the fire department and hotel staff to begin intervention according to the emergency plan. And by coordinating all these steps, the safe and rapid evacuation of people in the building is ensured. So as an example, a fire has started in a hotel room on the left and generating thick smoke. And this smoke escaping through the door and spreading into the corridor. Then ventilation ducts located at the top activate when the fire scenario is triggered. And the smoke is drawn in through these ducts and directed to the smoke extraction system at the top of the building, as you can see. And powerful fans at roof level expel the smoke to the outside and improving visibility and also breathability inside the building. In the central section, people are seen evacuating using the stairs, and the controlled removal of smoke makes escape routes safer. On the lower floor, people moving towards the exit indicate that the emergency evacuation is ongoing. So the standard says that in the 6.6.1, in areas where audible alarms may be ineffective, in other words, where background noise is excessive or hearing protection is likely to be compromised, visual and or tactile alarm devices should be used to supplement audible alarms. So in areas likely to be used only by hearing impaired persons, procedures should be implemented to inform them about the alarm. Visual and or tactile alarm devices should be used to supplement audible alarms. So in 6.6.2, the standard says that the sound level should not exceed 118 decibel at any point where people may be present. And also the sound used for fire alarm purposes shall be the same in all parts of the building. Also, the fire alarm sound should continue for more than 30 seconds, at least 65 decibel or 10 decibel above any noise, whichever is greater. If the alarm is intended to alert sleeping people, the minimum sound level at the bedside should be 75 decibel. And these minimum levels must be reached at any point where the alarm sounds need to be heard. In a campus or site with multiple buildings, the alarm sound must be the same for all buildings. In 6.6.3, for visual alarm devices, visual fire alarm devices must comply with EN 5423, and any visual fire alarm must be clearly visible and distinguishable from other visual signals used in the building, and visual alarm devices must be numbered and positioned so that they are clearly visible from any point in the area where they are used. So as we mentioned before, in areas likely to be used by hearing impaired individuals, procedures should be implemented to inform them about the alarm, and audible, visual, and tactile alarm devices should be used according to the usage characteristics of the area. And the vibration module can be generated during a fire via a relay module attached to the bed. So let's look at the statistics of hotel fires. The statistics on hotel fires show that the vast majority of such incidents can be brought under control with early intervention. So approximately 60 to 70% of fires are small scale and extinguished before they spread, while about 30% occur at night when guests are in their rooms, and the areas where fires most often start are guest rooms and kitchen areas. And thanks to the fire detection systems, sprinklers, and effective evacuation procedures, the death toll in hotels is lower compared to the residential buildings. However, material damage can often be high, and the primary cause of fires is electrical problems, accounting for approximately 30 to 40% of all fires, old or faulty installations, overloaded outlets, and malfunctioning electrical appliances are the main factors to leading to this. And this is followed by kitchen and cooking related fires at 20 to 30%, and the risk is particularly high in industrial kitchens and grease fires. And fires caused by cigarettes occur at 10 to 50%, usually due to smoking in rooms and not completely extinguishing cigarette butts. And fires originating from heating systems and equipment account for 5 to 10% of all fires, and usually caused by boilers, heating systems, or lack of maintenance. And also, human error and negligence are also a significant factor, accounting for 10 to 20%, and this includes the use of candles, leaving electrical appliances switched on, and the misuse of flammable materials. Although rarer, intentionally set fires account 1 to 5% and generally cause significant material damage. Overall, it is clear that a large proportion of hotel fires can be prevented from escalating through early detection and rapid intervention. So therefore, smoke detectors, addressable fire alarm systems, and effective evacuation scenarios are critical for both ensuring life safety and also minimizing material losses. So in the 86/666 EEC directive, the fire safety regulations for hotels, motels and resorts, enacted by the European Union and adopted and implemented in our country, aims to minimize fire risks in hotel, motel and resort buildings and to ensure the life safety of the people in the event of a fire. And according to this directive, all spaces in the building designed for accommodation purposes, such as bedrooms, corridors, or common areas, auxiliary facilities, training and sports halls, must be equipped with smoke detectors. Areas where smoke detectors might trigger false alarms, such as kitchen and boiler rooms, should be equipped with temperature sensors, temperature detectors, heat detectors. In addition, toxic gas, such as carbon monoxide detections, should be carried out in enclosed parking areas. Or explosive gases, LPG or LNG detections should be carried out in boiler rooms, kitchens, and other cooking areas. Furthermore, lowered ceiling spaces and spaces where cables are carried vertically and horizontally, such as shafts or galleries, should be equipped with smoke and temperature sensors of appropriate type and size. And alarm manual call points should be installed at all easily accessible points for both guests and staff to access in case of early fire detection. And all detections and alarms should be evaluated by the cause and effect software of the fire alarm control panel and should be able to generate actions appropriate to the building's emergency scenarios. And the fire alarm control panel should be located in a space where personnel and constantly present. This space is usually the reception area, but intervention areas such as the technical office or security and administrative office can also be used. Repeater control panels open to the supervision of teams can be installed also. And the fire detection and warning systems must be capable of monitoring the fire extinguishing system installed in the building, flow switches, line shut-off valves, and all control points. So the fire alarm system must have mechanisms to provide sufficient audible and visual warnings throughout the facility. And the system must have the ability to send messages, SMS or email, at night or when intervention teams are not present. Then the system must be able to transmit messages to local emergency response teams via a reliable telephone or other communication, means that TCP/IP or GPRS. So after a fire is detected by the control panel, the issuance of audible and visual warnings for evacuation can be delayed by a few minutes. So as soon as the necessary intervention teams see the fire message on the control panel, they go to the address from which the alarm is originated and confirm the smoke and flame effects of the fire and then issue evacuation warnings. So in this way, all guests are not disturbed in case of false alarms, or when gas is detected in kitchens, other cooking areas, or boiler rooms and storage areas related to flammable and explosive gases. An automatic gas shut-off operation should be performed at the gas supply points or centrally. So when toxic gas, carbon monoxide, such as levels increase in parking garages, and the ventilation system must be automated by issuing the necessary commands. Doors that slow down smoke flow in the floor corridors should be in place during a fire, and these doors normally held closed with magnetic door holders. And also should be released and closed in case of fire, controlled by the fire alarm scenario. And all enclosed escape stairwells and elevator shafts must be equipped with a pressurization system in case of fire. And these pressurization systems must be activated under the control of the fire alarm system. So comfort ventilation and smoke exhaust ventilation controls in the building should be managed by the fire alarm system. All elevators should be directed to the emergency exit floor by the fire alarm system in case of a fire. So, as a result, according to the regulation on fire protection of buildings in our country and the CEN 5414 standard referenced in this regulation, fire detection and alarm systems are designed, implemented, and operated in hotels. So in conclusion, fire detection and alarm systems are critically important for both life and property safety in preventing potential fires in hotels. Furthermore, after the installation, commissioning, and testing, training, and also acceptance of fire detection and alarm systems in hotels, it is essential that operation and maintenance processes are carried out optimally and completely to ensure their continued functionality. In our country, the operation and maintenance services of fire detection and alarm systems must be carried out in accordance with the provisions of the Regulation on Fire Protection of Buildings and the principles specified in the TS-CEN TS 5414 standard. So thanks for your participation. Next week we will be meet again at 11 a.m. See you soon.